The rectangular arrangement of elements in rows and columns is called a matrix. Number of rows and number of columns are equal, then it is called a square matrix. The horizontal lines are called as the rows and the vertical lines are called as the columns. A square matrix in which all the non-diagonal elements are zeros is called a diagonal matrix. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhashram PU College, the Temple of Excellence. Today in this session I am going to take the revision of chapter 3, that is very important chapter and the easiest chapter, matrices. The first part is the matrices and the next chapter is the determinants. Now let us know regarding matrices. So in this session I am going to discuss regarding 1 mark question, 2 marks question and 3 marks questions which are appear for the final examination. Now let us come to the 1 marker question. Before that, let us know what is the weightage for this chapter. So in this chapter you are going to get one 1 mark question, one 2 mark and one 3 marks and one 5 marks question. So totally 11 marks from this chapter. 1 mark 1 question, 2 mark 1 question, 3 mark 1 and one 5 marker question in part D. Right. Now let us come to the 1 mark question. Let us know regarding the definition. What is the definition? You might have been studied regarding the definition and different type of matrices. Let me recall the definition and very important type of matrices. Now what is a matrix? A matrix is nothing but a rectangular arrangement of elements. The rectangular arrangement of elements in rows and columns is called a matrix. The rectangular array, the rectangular arrangement of elements in rows and columns is called as a matrix. The horizontal lines are called as the rows and the vertical lines are called as the columns. So these are called as the rows, R1, R2 and R3. They are called as the rows, and the vertical lines, these are called as the columns. So C1, C2 and C3 are called as the columns. So the arrangement of these in a square bracket or a small bracket between two brackets like this is called a matrix. So the arrangement of elements in rows and columns is called a matrix. The horizontal lines are called the rows and the vertical lines are called as the columns. So this is first row and second row. 1, 5, minus 9 is in first row, 2, 4, 5 is in the second row. This is column 1, column 2, column 3. 1, 2 first column, 5, 4 second column, minus 9, 5 is in the third column. So similarly here 1 row, 2 row, 3 rows, 1 column, 2 column, 3 column. So this is a matrix. The horizontal lines is called as a rows and the vertical lines is called as a column. Now by knowing this, let us know regarding the order of a matrix. The order of a matrix is nothing but order of a matrix will determine the number of elements present in a matrix. Therefore order is equal to rows into column. The number of rows into number of columns will give the order. So in this example, what is the order? This contains 1, 2, 2 rows and 1, 2, 3, 2 rows, 3 column. So the order for this matrix is 2 rows, 3 column. So therefore this contains 6 elements. Here what is the order? It contains first row, second row, third row, first column, second column, third column. Therefore the order for this matrix is 3 into 3, 3 rows and 3 column. So this is regarding the definition of a matrix and an order. Depending upon the order, the matrices are classified into row matrix. Row matrix means a matrix having only one row is called a row matrix. A matrix having only one column is called as a column matrix. The very important matrix is a diagonal matrix. Before that, a square matrix. Square matrix means number of rows is equal to number of columns. A matrix in which number of rows and number of columns are equal, then it is called a square matrix. Let us come to the very important 1 mark question. In the examination they may ask, define a diagonal matrix. A square matrix A is said to be a diagonal matrix if non-diagonal elements are 0. If all the elements are zeros except the principal diagonal elements. A square matrix in which all the non-diagonal elements are zeros is called a diagonal matrix. This is an example for a diagonal matrix. A is equal to 2, 0, 0, 0, 4, 0, 0, 0, 5 is an example for a 3 rows, 3 column diagonal matrix. Here these are the diagonal elements. So 2, 4, 5 are the diagonal elements. Other than this, all the elements are 0. All the non-diagonal elements are zeros. It's a square matrix in which all the non-diagonal elements are zeros. Then it is called a diagonal matrix. is a diagonal matrix of order 3. That is, all the elements are zeros except the principal diagonal elements. Let me take one more example. If P is equal to 2, 0, 0, 0, 4, 0, 0, 0, 7, this is also an example for a diagonal matrix. In case of 2 rows, 2 column, 2, 0, 0, 5, this is also an example for a diagonal matrix. Now, move on to the next one, scalar matrix. Scalar matrix is an example for a diagonal matrix. So, scalar matrix means it is a diagonal matrix in which all the diagonal elements are same. A matrix is said to be a scalar matrix if all the diagonal elements are equal. A diagonal matrix is said to be a scalar matrix if all the diagonal elements are same. Example 5005. This is an example for a scalar matrix of order 2 rows 2 column. This is also an example 300, 030, 003 is an example for a scalar matrix of order 3 cross 3. So, these two are example for scalar matrices of order 2 and 3. Let us take one more example. P is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is also an example for a scalar matrix. That means all the diagonal matrices, all scalar matrices are example for diagonal matrices, whereas all diagonal matrices are not scalar matrices. Now, let us move on to the next, identity matrix or a unit matrix. Identity or a unit matrix. That means a square matrix in which all the principal diagonal elements are equal to 1 and the other elements are zeros, and it is denoted as I. It is also an example for a diagonal matrix in which all the diagonal elements are equal to 1. This is also an example for a scalar matrix in which all the diagonal elements are equal to 1. So, a matrix in which all the elements are 0 except the principal diagonal elements, and if the principal diagonal elements are equal to 1, then it is called an identity matrix denoted as I. 1001 is an example for an identity matrix of order 2 rows 2 column. 100, 010, 001 is a matrix, identity matrix of order 3 rows and 3 columns. So, identity matrix, or it is called as a unit matrix. It is a square matrix in which all the principal diagonal elements are equal to 1, other elements are 0. Or you can also say it is a scalar matrix in which all the diagonal elements are equal to 1. Or it is a diagonal matrix in which all the principal diagonal elements are equal to 1. So, denoted as capital I. Now, move on to the next one, zero matrix or a null matrix. In the examination they may ask, define a zero matrix or a null matrix. Null zero means, yes, matrix, whatever may be the order. A matrix in which all the elements are 0 is called a null matrix or a zero matrix, and it is denoted as 0. This is a null matrix of order 1 into 1. This is a null matrix of order 2 rows 2 column, and this is a null matrix of order 2 rows and 3 column. So, a null matrix of order 3 rows 3 column is denoted as 0 is equal to 0, 0, 0, 0, 0, 0, 0, 0. This is a null matrix of order 3 rows 3 column. So, a matrix in which all the elements are zeros, then it is called a null matrix denoted as 0. Now, these are a few important types of matrices. Move on to one more question. Usually in the examination they may ask the questions like this. If a matrix has 8 elements, what are the possible orders we can have? So, actually in the beginning itself I explained the order of a matrix is nothing but rows into column. The order of a matrix will determine the number of elements present in a matrix. If a matrix contains 8 elements, then what are the possible orders? So, a matrix having 8 elements, then what are the possible order means 1 into 8, 1 comma 8, 1 into 8, again 2 into 4, 2 4s are 8, again 4 into 2, 4 2s are 8, and again 8 into 1. See here. So, 1 into 8 is 8, 2 into 4 is 8, 4 into 2 is 8, 8 into 1 is 8. So, therefore, the possible orders, are, what are the possible orders? 1 comma 8, 2 comma 4, 4 comma 2 and 8 comma 1. So, there are 4 possible orders. Suppose if a matrix contains 8 elements. Now, move on to the next problem. Write all the possible orders if a matrix contains 13 elements. So, here this contains 13 elements. So, therefore, the possible orders are 1 comma 13 and 13 comma 1. So the possible order, so here you can't divide 13 by any other number except 1 and the same number. So what is the order you are going to get? You are going to get the matrix of order 1 comma 13, that is 1 cross 13 and 13 cross 1. 1 into 13 is 13, 13 into 1 is also 13. So you will get two matrices of order 1 and 13 comma 1, that is 13 into 1. That's it. This is very important for 1 mark. Move on to the next problem. So usually you will get 1 mark questions like this also. Construction of the matrices. So construct a 2 cross 2 matrix where the elements A is equal to Aij is of the form I by J. Now you might have been studied in the definition itself. A matrix can also be represented as, the general representation of a matrix is A11, A12, A13, A21, A22, A23 and A31, A32 and A33. This is a matrix of order 3 rows and 3 column. Now what is the problem given here? Construct a matrix of order 2 rows 2 column. For 2 rows 2 column, now let us consider a matrix of order 2 rows 2 column. 2 rows 2 column A11, A12, A21 and A22. This is 2 rows 2 column, this matrix. Right. What is the condition given this matrix? I by J, I 1 by 1, again 1 by 2, 2 by 1, again 2 by 2. 1 divided by 1 is 1, 1 by 2 as it is, 2 by 1 is 2, 2 by 2 is 1. So this is a matrix of order 2 rows 2 column. That's it. Okay. Now move on to a similar type problem. What is the problem? Construct a 2 cross 3 matrix. What is the order? 2 into 3. Where the elements of matrix A, Aij is equal to I minus j whole the square. Now, A is equal to 2 rows, 3 column. 2 rows A11, A12 and A13, A21, A22, A23. What is the order? This contains 2 rows, 1, 2 and 3, 3 columns. 2 rows and 3 columns. Now, what is the condition given? I minus j whole the square. I minus j whole the square. So, therefore, this can be written as 1 minus 1 whole square, 1 minus 2 whole square, 1 minus 3 whole square. Second row, for second row, this is 2 minus 1 whole square, 2 minus 2 whole square, 2 minus 3 whole the square. Now, what is this equal to? 1 minus 1 is 0 square is 0, 1 minus 2 is minus 1 square is plus 1, 1 minus 3 is minus 2 square is plus 4, 0, 1, 4. Again 2 minus 1 is 1 square is 1, 2 minus 2 is 0 square is 0, 2 minus 3 is minus 1 square is plus 1. So, this is the required matrix of order 2 rows and 3 column. That's it. Okay. Very simple for 1 mark. Now, move on to the next question, that is 2 marker question. So, these are based on the equality of matrices. So, find the value of x, y and z from the given equation, x plus y plus z, y plus z and x plus z is equal to 9, 5 and 7. Now, by equality of matrices, let us equate it. X plus y plus z is equal to 9. Let us represent this as equation number 1. Next, x plus z is equal to 5. Let us represent this as equation number 2. And y plus z is equal to 7, equation number 3. Now, let us solve these 3 equations to get the value of x, y, z. Now, let us consider equation number 1 and equation 3. From 1 and 3, what is 1? X plus y plus z is equal to 9. Since from 3, what is 3? Y plus z is equal to 9. Since y plus z is equal to 7. Substitute here, y plus z is equal to 7. X plus 7 is equal to 9. Therefore, x is equal to 9 minus 7 is equal to 2. The value of x is equal to 2. First value of x is 2. Right. Now, from this, from equation number 2, from 2, what is x plus z? X plus z is equal to 5. Therefore, z is equal to 5 minus x. 5 minus, what is x? X is equal to 2. 5 minus 2 is 3. So, z is equal to 3. Right. Now, similarly, what is to find? So, you got x and z, y from equation number 3. From 3, y plus z is equal to 7. Y plus z is equal to 7. Therefore, y is equal to 7 minus z. 7 minus What is z? Z is equal to 3. 7 minus 3 is equal to 4. So y is equal to 4. Now what are the values? Therefore, here therefore x is equal to, I'll write here, therefore x is equal to 2, y is equal to 4 and z is equal to 3. So 2 comma 4 comma 3. For verification, just add x plus y plus z is equal to 9. 4 plus 3 7, 7 plus 2 is 9. So if you add, you will get 9. X plus y plus z is equal to 9. That's it. So if you do this much, definitely you will get 2 marks. Now move on to the next problem. Same type. If x plus y 3, x minus y minus 6, 2, 3, 4 minus 6 are equal, then find the value of x and y. So again same, by equality of matrices, by equality of matrices, equate it. X plus y is equal to 2 and x minus y is equal to 4. So remaining these two are equal. Solving this, solving x plus y is equal to 2 and x minus y is equal to 4. Now let us add this. If you add, what happens? Minus y plus y gets cancelled. X plus x is 2x is equal to 6. X is equal to 6 by 2 is equal to 3. X is equal to 3. See here, just by equality x plus y is equal to 2 and x minus y is equal to 4. Add, minus y plus y gets cancelled. 2x is equal to 6. X is equal to 6 by 2 is 3. Now from this, now from any one of these two equations, from x plus y is equal to 2, y is equal to 2 minus x. 2 minus, what is x? X is minus. So 2 minus 3 is minus 1. So therefore y is equal to minus 1. So therefore the value of x is equal to 3 and y is equal to minus 1. That's it. See, if you want, you can add 3 minus 1, 3 minus 1, x plus y, 3 minus 1 is 2, x minus y, 3 minus into minus plus 3 plus 1 is equal to 4. You will get the answer. That's it. Okay. Now move on to the next problem. Let us take some problems on operations on matrices. So you might have been studied regarding addition, subtraction, scalar multiplication and matrix multiplication of matrices. Addition of matrices, subtraction of matrices, that is the difference of matrices, and scalar multiplication as well as the matrix multiplication. Now let us take few problems on addition, subtraction and scalar multiplication and matrix multiplication. Now what is the problem given? A is equal to 2, 4, 3, 2 and B is equal to 1, 3, minus 2, 5. Find A plus B. First A plus B. Addition. What is A? 2, 4, 3, 2 plus B. B is 1, 3, minus 2, 5. Corresponding elements must be added. That's it. 2 plus 1, then 4 plus 3. Again second row, 3 minus 2 and 2 plus 5. So this is equal to, if you add, 2 plus 1 is 3, 4 plus 3 is 7, 3 minus 2 is 1, 2 plus 5 is 7. This is the required answer for A plus B. See, just A and B. Second one, what is the second one? Similarly, A minus B. What is A? A is 2, 4, 3, 2 minus B, 1, 3, minus 2 and 5. Subtract this. So 2 minus 1, 4 minus 3, again 3 minus into minus plus, 3 plus 2, again 2 minus 5. What is this equal to? 2 minus 1 is 1, 4 minus 3 is 1, 3 plus 2 is equal to 5 and 2 minus 5 is minus 3. The answer is 1, 1, 5 minus 3. That's it. This is addition and subtraction. Move on to the next problem. Now compute the following matrices. So what is given? Cos square x, sin square x, sin square x, cos square x plus sin square x, cos square x, cos square x, sin square x. Now add this. What is this equal to? Cos square x plus sin square x, again sin square x plus cos square x, then sin square x, cos square x, sin square x plus cos square x, again cos square x plus sin square x. What is this equal to? So you know the formula in identity, that is, since sin square theta plus cos square theta is always equal to 1. Sin square theta plus cos square theta is 1. So this is sin square x plus cos square x is 1, again this is 1, again this is 1 and 1. The required answer is 1, 1, 1, 1. Is a matrix of order 2 rows, 2 column. Now move on to the next problem. Same, if x into 2 3 plus y into minus 1 1 is given to be 10 and 5, find the value of x and y. Just simplify this. Now this is called scalar multiplication. Multiply by x 2x 3x plus multiply by y minus y and plus y is equal to 10 and 5. Just add this. If you add 2x minus y, this is 3x plus y is equal to matrix 10 and 5. Now by equality of matrices, you can write 2x minus y is equal to 10 and 3x plus y is equal to 5. Solving 1 and 2. Solving these two equations, 2x minus y is equal to 10. Another one is 3x plus y is equal to 5. Solving these two equations, 2x minus y is equal to 10 and 3x plus y is equal to 5. Now add this. If you add, plus y minus y gets cancelled, 2x plus 3x is 5x is equal to 15. X is equal to 15 by 5 is equal to 3. So therefore x is equal to 3. Now from any one of these two equations, let us take this one, 3x plus y from 2, 3x plus y is equal to 5. Y is equal to 5 minus 3x. This is 5 minus 3 into x is 3. So 5 minus 9. 5 minus 9 is minus 4. Y is equal to minus 4. So therefore, the value of x is equal to 3 and value of y is equal to minus 4. 3 and minus 4. So if you want to verify, you can verify it. So if you want for the verification, let us take any one of these two equations. That is 2x minus y is equal to 10. Substitute the value. What is x? X is equal to 3 minus y. Y is equal to minus 4. So 6 minus into minus plus, that's equal to 10. This is how we are going to verification. That's it. This is how we are going to solve the problem. Now move on to the next problem. If a plus b and a minus b are given, find the value of a and b. Now what is given here? A plus b. A plus b is equal to 7, 0, 2, 5 and a minus b 2, minus 2, minus 1 and 5. Let us add this. If you add, what happens? Minus b plus b gets cancels. 2a is equal to addition. 7 plus 2 is 9. 0 minus 2 is minus 2. 2 minus 1 is 1. 5 plus 5 is 10. This is 2a. So therefore a is equal to half of this matrix, 9 minus 2 1 10. So this is equal to 9 by 2 minus 2 by 2 is 1, 1 by 2 and 10 by 2 is equal to 5. This is the value of a. That's it. Just add, you will get the value of a. Now to get the value of b, now from any one of these two equations, from a plus b is equal to 7, 0, 2, 5. Now what is required to find? B. Therefore b is equal to this matrix 7, 0, 2, 5 minus a. 7, 0, 2, 5 minus a. What is a? 9 by 2 minus 1, 1 by 2 and 5. Simplify this. 7 minus 9 by 2, 0 minus into minus plus 1, 2 minus 1 by 2 and 5 minus 5. So this is equal to, so therefore the value of b is equal to the matrix. Take LCM, 2 is the LCM, 7 2s are 14. 14 minus 9 is 5 by 2. 7 2s are 14, 14 minus 9 is 5. 0 plus 1 is 1. Here 2 is the LCM again, 2 is the LCM, 2 2s are 4 minus 1 is 3 by 2, 5 minus 5 is 0. That's all. So 5 by 2, 3 by 2, 1, 0 is the value of the matrix B. That's it. So therefore, I'll write here A, matrix A is equal to 9 by 2 minus 1, 1 by 2 and 5. B is equal to, matrix B is equal to 5 by 2, 1, 3 by 2 and 0. That's it. These are the values of matrix A and B. That's it. Hope you followed. Now move on to the next problem. This is again comes to the matrix multiplication. So far we have discussed regarding addition, subtraction, scalar multiplication. Now it is matrix multiplication. So, very important concept in matrix multiplication is, if A is a matrix of order m into n, B is a matrix of order n into p, if these two are equal, then only the matrix AB is obtained and is of order m into p. That means, this is, you know, the order is rows into column, rows into column. The number of columns in first matrix is equal to number of rows in the second matrix, then only it is possible to multiply, then you are going to get the matrix of order m into p, that is rows into column. Now, since this is a matrix of order 2 into 2, this is a matrix of order 2 into 3, so these two are equal, it is possible to multiply and we will get a matrix of order 2 into 3. What is A? 6, 9, 2, 3 into B 2, 6, 0, 7, 9, 8. Now, so just first row, first column, second column, third column. 6 2s are 12, again 9 7s are 63. So, first row, first column, same row, second column, 6 6 are 36 plus 9 9s are 81. First row, second column, again same row, first row, third column, 0 into 6 is 0, 9 into 8, 72. That's it, right. So, here first row, first column, second column, third column. Similarly, 2 2s are 4, second row, first column, second column, third column. 2 2s are 4, 3 7s are 21, again 2 6 are 12 plus 3 9s are 27, again 2 into 0 is 0 plus 3 into 8 3s are 24. Now, this is equal to, what is this equal to? 63 plus 12. So, 3 plus 2 is 5, 6 plus 1 is 7, 75. 36, 6 plus 1 is 7, 8 plus 3 it is 11, 113, 117. This is 0 plus 72 is 72. Again 21 plus 4 is 25, 7 plus 2 is 9, 2 plus 1 is 3, 39. This is 24. So, what is the order? 2 rows and 3 columns. 2 into 3. This is the required answer. That's it. This is how we are going to find AB. Okay. Move on to the next problem. Now, if A dash is given, B is given, find A plus B dash. See, A dash is given. Now, therefore, A is equal to, A dash is the transpose of A. So, here already A dash is given, transpose this. That's all. What is A? Minus 2, 3 and 1 comma 2. If you transpose this, you will get A dash. B is given. What is required to find is A plus 2B whole dash. Now, first find out A plus 2B. What is A? A is this. A is equal to minus 2, 1, 3, 2 plus 2 times matrix B, minus 1, 0, 1, 2. So, that's equal to minus 2, 1, 3, 2 multiply by 2, minus 2, 0, 2, 2 2s are 4. Add this. Minus 2 is minus 4, 1 plus 0 is 1, 3 plus 2 is 5, 2 plus 4 is 6. Now, this is A plus B. Now, therefore, what is required to find is A plus 2B whole dash. The whole transpose is minus 4, 1, 5 and 6. This is the required answer. That's it. Minus 4, 5, 1, 6 is the required answer. That's it. Now, let's move on to the next problem. If A is equal to 1, minus 1, 2, 3, B is equal to 2, 1, 0, 1, find the matrix X such that what is given? 2A plus X is equal to 3B. Very simple problem. Given 2 into matrix A plus capital X is equal to 3B. What is required to find is X. So, X is equal to 3B. Transfer this minus 2A. That's all. 3 into substitute B. B is 2, 1, 0, 1. Minus 2 into substitute A. A is 1, minus 1, 2 and 3. Multiply this. So, 2 3s are 6, 3 1s are 3, 3 into 0, 0, 3 1s are 3, minus 2 1s are 2, 1 2s are 2, 2 2s are 4, 2 3s are 6. Subtract this. 6 minus 2, 6 minus 2 is 4, 3 minus into minus plus 3 plus 2 is 5. 0 minus 4 is minus 4, again 3 minus 6 is minus 3. So, therefore, the matrix X is equal to 4, 5, minus 4, minus 3 such that 2A plus X is equal to 3B. That's it. Okay. So, you followed this. Listen. 2A plus X is equal to 3B, X is equal to 3B minus 2A, 3 into B, 2, 1, 0, 1 minus 2 into A, 1 minus 1, 2, 3. So, 3 2s are 6, 3 1s are 3, 3 into 0, 0, 3 1s are 3, again 2 1s are 2, 2 1s are minus 2, 2 2s are 4, 2 3s are 6, 6 minus 2 is 4, minus into minus plus 5, 0 minus 4 is minus 4, again 3 minus 6 is minus 3, that's it. Now, move on to the next problem, the last problem in this. This is also very important for 2 or 3 marks. If A is equal to 3 root 3 2 4 2 0 and B is equal to 2 minus 1 2 1 2 4, show that A plus B whole dash is equal to A dash plus B dash. First find out A plus B. What is A plus B? 3 root 3 2 4 2 0 plus 2 minus 1 2 1 2 4. Add this. If you add, what you are going to get? So this is 3 plus 2 is 5. Again root 3 minus 1. Again 2 plus 2 is 4. Again 4 plus 1 is 5. 2 plus 2 is 4. 0 plus 4 is 4. Now therefore transpose this. A plus B whole dash. The transpose of this is 5 root 3 minus 1 4 5 4 and 4. Let us represent this as equation number 1. Just find out A plus B and transpose it. Now move on to the next. This is LHS. Call it as LHS. Now move on to the right hand side. What is right hand side? A dash plus B dash. Now what is A dash? Transpose of A. This is 3 root 3 2 and 4 2 0 plus what is B dash? The transpose of this 2 minus 1 2 1 2 and 4. Add this. What is this equal to? 3 plus 2 is 5. 4 plus 1 is 5. Again 3 minus 1 is root 3 minus 1 as it is. 2 plus 2 is 4. Again 2 plus 2 is 4. 0 plus 4 is 4. Let us represent this as equation number 2. See what is equation 1 and 2. Equation 1 and 2 contains same elements 5 5 root 3 minus 1 4 4 4. So from 1 and 2 we can say that therefore from 1 and 2 LHS is equal to RHS. LHS is equal to RHS. That means therefore A plus B whole dash is equal to A dash plus B dash. This is how we are going to verify. If you want, you can verify this property also. Similarly, you can write A minus B whole dash is equal to A dash minus B dash. So in the examination, if they ask A plus B whole dash is equal to A dash plus B dash and A minus B whole dash is equal to A dash minus B dash, means definitely you will get a question for 5 marks. So you may expect 5 marks from that question. This is how we are going to solve 1 mark and 2 marker questions. So so you may expect this type of questions for your examination. So these are all questions from the previous year question papers. So 1 marker and 2 marker questions. So that is regarding types of matrices, definition, order and operations on matrices like addition, subtraction, scalar multiplication and matrix multiplication. So that's all regarding our today's session. Let us meet with a different concept in the next session. Thank you very much.